Hi everyone, welcome to Phew, that's a relief, assessing drinking water quality and treatment of water supply. My name is Jarren Santos and I recently graduated from Grinnell College. Let's go ahead and get started. Here's the introduction. We'll start off by saying that access to safe drinking water is a basic human right, but not every state has necessarily taken measures to protect this right. In 2015, an Iowan town found that the level of lead in their water supply is 3 times higher than what is considered safe by the Environmental Protection Agency. Consumption of water containing chemicals such as lead can raise the risk of long-term health consequences, thus directly affecting population health. One way to improve the water quality at a quick, affordable cost is the implementation of a point-of-use device such as water pitcher filters. There are a wide variety of water pitcher filters that vary in the contaminants they remove, and we want to note that water filters have been celebrated as exemplary advancements in engineering that can benefit populations with limited access to safe drinking water. During the time of conducting this project, we were fourth-year students at Grinnell College, and so we had heard a variety of remarks about the quality of drinking water from the student body. First-year students tended to make comments about how the water at the institution has a strange taste compared to where they came from, and then some of the upperclassmen who moved onto off-campus locations not supervised by Grinnell College said that they felt more skeptical about the water quality of their homes. With this motivation, we decided to design an experiment that tested the quality of drinking water from the different locations around Grinnell College and to see if water filters were actually effective in improving water quality. So here is the methodology. So in terms of measurement, we chose pH level as our measure for water quality, and in terms of safe drinking water, the pH range should be between 6.5 to 8.5 to indicate that the water is safe to drink. So for collecting data, we randomly chose the order to visit types of locations within a day. And so for each location, we randomly selected a building. At each of these buildings, we found the nearest kitchen sink to collect water from. If there was no kitchen sink, we would then use a water fountain. We then collected one sample using a Brita pitcher with standard filter and one sample using a Brita pitcher without any filtration device from each building. We then transferred these samples over to the laboratory where we then recorded the pH level. We then repeated this for 6 consecutive days. So in these pictures, we have a academic building on the top left building, that's the Joe Rosenfield Center. On the bottom left, we have a residence hall, that is Cleveland Hall, and on the right, we have a picture of an off-campus house. In terms of the experimental design and analysis, we designed this experiment as a factorial design. And so our two factors in this case are location and filtration treatment. Within location exists academic building, residence hall, and off-campus residence. And within filtration treatment, it's either filtered or not filtered. We had 6 treatment combinations and 6 replicates for each, and so that resulted in a total of 36 observations. We then used SAS version 9.4 to conduct a two-way ANOVA, and afterwards, if there were significant differences or significant results, we used Tukey's test for multiple comparisons to identify which groups were significantly different. Now we have the results. Here we have a box plot of the pH levels of drinking water around Grinnell College based on location. So we can see that there's a significant difference between the groups, and due to Tukey's multiple comparisons, we know that the groups are different when we look at academic and residence hall buildings versus the off-campus house locations. We then note the differences between the filtration treatment, and so we note a statistically significant difference between water that has been treated with the Brita filter versus water that has not been treated with the Brita filter. And we can see that water that has been filtered, has a much lower pH level. Here we have the effect of interaction, and that was found to be significant. This means that the effect of location depends on the effect of water filter treatment. Now we have the discussion that we're going to go over. And so we want to note that the effect of location on water quality, we see that off-campus locations have a significantly lower pH level than that of academic buildings as well as residence hall buildings. With regards to the effect of location on water quality, we note that water treated with a Brita standard filter has a significantly lower pH level than water left untreated, and that's kind of expected due to the fact that running drinking water through a Brita standard filter purifies it. The Brita standard filter can remove chlorine, copper, cadmium, mercury, and zinc. And then if we were to also use filters of different quality, so for example, if we used a filter known to remove the effects of stronger metals as well as nastier chemicals, we might see an even more stark difference between the filtration treatments. With regards to the interaction plot, there is a significant interaction effect between the factors of location and treatment. Um, Note that this is mainly due to the off-campus locations and treatment effect interaction. So we kind of contribute this to the idea that drinking water in commercial buildings, such as those found at Grinnell College, may already have their water filtered prior to distribution, while as drinking water off campus may come directly from the water source, which means that off campus water may have a bigger pH decrease when treated with the Brita standard filter. We also want to note some limitations with our experiment. So some of our diagnostic plots indicated minor issues with non-constant variance and deviation from normality. And so to solve this, we could increase our sample size for the experiment in the future. And also we want to note that studies have used other recorded measures, such as amounts of a specific organic compound, that may actually be a better indicator in terms of water quality. So in conclusion, we have three main takeaways. Off-campus drinking water has a significantly lower pH level than the other places. Using a Brita standard filter can significantly reduce the pH level of drinking water. The biggest takeaway, though, is that all of our samples are within the recommended range for safe drinking water, so significant differences in pH levels of drinking water should not be mistaken with an increase or decrease in the water quality. So in terms of our resources, we have the code book variables that we used when doing our data collection. We have the outputted ANOVA table from SAS version 9.4. We also have the diagnostic plots outputted from the same software. We would also like to acknowledge the following groups and individuals for helping us with this academic endeavor and recognizing the merits of our project. And here are our references. If you have any questions, please don't hesitate to contact us, and we're glad you can listen to our presentation. Thank you so much.